Welcome. Today we will see Chapter 3 Block Diagram Representation. Syllabus: Block Diagram Algebra, General Representation of Feedback Control System, Transfer Functions, Rules of Block Diagram Algebra, Reduction of block diagram to obtain closed loop transfer function. Introduction. Block diagram is a pictorial representation of a given system. It is very simple way of representing the given complicated practical system. In a block diagram, the interconnection of system components to form a system can be conveniently shown by the blocks arranged in a proper sequence. It explains cause and effect relationship existing between input and output of the system through the blocks. To draw the block diagram of a practical system, each element of practical system is represented by a block. The block is called as functional block. It means that block explains mathematical operation on input by the element to produce the corresponding output. A control system for regulating the level of fluid in a tank is done by adjusting the output valve. The automatic operation is done by operating the valve to maintain the level of fluid. Accordingly, if water level rises or falls below desired level, automatic operation of the valve takes place and water level is maintained. Now see this diagram, that is automatic control system to regulate the flow of water in the tank. How it consists of this tank, then float is there. Float is nothing but one feedback element. With the help of float we are getting whether desired height is obtained or not. Now this is the inlet pipe through which water is flowing inside the tank. This is the pivot. This is the bell crank lever arrangement is there. One end of which float is connected with the help of this screw, and other end this valve is there, that is this knob is there. Now what will happen when this water is coming inside the tank? Water level rises and similarly this float will raise. Now when the float is going to reach up to desired height, that is this dV, at that time what will happen? This float position is at this position. Now when it will touch this black line, at that time what will happen? This lever, other end of the lever will come down and it will regulate or it will stop the flow of water inside the tank. That means with the help of float we are getting whether desired height of water is reached in the tank or not. Now again you see same diagram is there. This is the tank, this is the water level, this is the inlet pipe through which water is coming inside the tank, this is the outflow, this is the float. Float indicates water level. This is the controller. This controller operates this pneumatic valve. Now you just see this diagram, whole diagram is represented by this block diagram. What is our input? Desired level, reference input. It is fed to the controller. Then controller operates pneumatic valve. Pneumatic valve operates that water coming inside the tank. Now this is the feedback. This signal is the feedback signal. Therefore this feedback signal is taken by this float, and this float gives that signal to the controller, that is whether the desired height is reached or not. Then this controller again operates pneumatic valve. Again water is coming inside the tank. Again signal is taken from the float, that is feedback element. Feedback signal is there. Again it is fed to the controller. This will reach, or this cycle will take place until the actual level will be equal to the desired level. Now you just see here again, this water is coming inside the tank. This float is going to give signal to this controller. This controller is going to operate this pneumatic valve. This controller is going to operate the pneumatic valve until and unless the desired level is equal to the actual level. When the actual level is reached, then this float will give signal to the controller. Again this controller will operate pneumatic valve, and if desired level is equal to actual level, this controller will stop or will operate the pneumatic valve, and which will stop the inflow of the water inside the tank. Therefore this whole diagram is represented by this block diagram. In case of block diagram, we are having one input, then controller, then some system elements are there, then actual position. Again feedback is taken from that last variable, that is output variable. Again it is fed back to the controller. This cycle will go on continuing till the actual level will be equal to the desired level. For a closed loop systems, the function of comparing different signals is indicated by the summing point, while a point from which signal is taken for the feedback purpose is indicated by takeoff point in a block diagram. Therefore, in the block diagram there are different elements. First is input signal, then this summing point is there, it is represented by circle. That input signal is fed to the summing point. Again from the summing point another signal is there, that is error signal. Error signal is nothing but difference between input signal and this feedback signal, or this output signal and feedback signal. Therefore again that error signal is fed to the controller, then controller operates the process to be controlled. Then this control CT is nothing but control output. Again from this point feedback is taken. Therefore the point from which feedback is taken is known as takeoff point. Again it is feedback signal is taken by feedback element, and this feedback signal is fed back to the summing point or error detector. Therefore here RT is equal to reference input, ET is equal to error signal, CT is equal to control output, MT is equal to manipulated signal, VT is equal to feedback signal. All these summing points, blocks, takeoff points then must be connected exactly as per actual elements connected in the practical system. The connection between the blocks is shown by lines called as branches of the block diagram. An arrow is associated with each and every branch, which indicates the direction of flow of signal along the branch. The signal can travel along the direction of an arrow only. It cannot pass against the direction of an arrow. Hence, block diagram is an unilateral property of the system. In short, any block diagram has following basic elements. First is blocks, second transfer function of elements inside the blocks, third summing point, fourth takeoff point, and fifth arrows. All the blocks given in the system are reduced to one single block known as canonical form with the help of some rules of reduction of block diagram to calculate ratio of output to input. Now next point, general representation of closed loop and transfer functions. Now this is the figure, same figure is there. RS is nothing but reference input. Then this summing point is there. At the summing point, two signals are there, this input signal and this feedback signal, BS plus minus BS. Now RS plus minus BS is nothing but error signal, ES. It is fed back to this block having its transfer function GS. Then from GS or this block, an output is there, that is output signal CS. This path is known as feed forward path. Now from this output signal, one signal is taken off and this point is known as takeoff point. Therefore this takeoff point or this is known as feedback signal. It is fed back to this feedback element. This feedback element passes that feedback signal to the summing point. This is nothing but the block diagram. This path from left to right is known as feedback path. From right to left is known as feedback path, and from left to right, that is, it is known as feed forward path. A simple form of a closed loop control system is shown in adjacent figure. A block diagram in which forward path contains only one block, feedback path contains only one block, one summing point and one takeoff point represents a simple canonical form of a closed loop system. Now same diagram is there. We are going to derive one equation. Therefore RS is nothing but reference input, CS is nothing but controlled output, ES is nothing but error signal, BS is equal to feedback signal, GS is equal to equivalent forward path block transfer function, HS is equal to equivalent feedback path block transfer function. Now again same figure is there. Now from this block diagram we are going to write some equations. Therefore ES is equal to, this ES is equal to RS plus minus BS, equation 1. Now BS is equal to CS into HS, because this signal we have taken, the value of this signal is CS. Therefore CS into HS. Therefore BS is equal to CS into HS, equation 2. Now CS is equal to ES into GS. CS is equal to ES into GS, equation 3. Therefore from equation 1 and 2 we have, now what we have to do, we have to substitute value of BS in equation 1. Therefore ES is equal to RS plus minus CS into HS, equation 4. Also from equation 3, what is our equation 3? CS is equal to ES into GS. Therefore ES is equal to CS upon GS, that is equation 5. Now we will substitute value of ES, that is equation 5, in equation 4. Here we will substitute. Therefore from equation 4 and equation 5 we have RS plus minus CSHS is equal to CS upon GS. Therefore CS is equal to RS into GS plus minus CS HS GS by doing cross multiplication. Therefore RS into GS is equal to CS plus minus CS HS CS into HS into GS. Now we will take CS common. Therefore RS into GS is equal to CS into bracket 1 plus minus GS HS. Therefore we will find out CS is equal to, therefore CS is equal to RS into GS divided by into bracket 1 plus minus GS HS. Therefore CS upon RS, this RS will take towards left side, CS upon RS is equal to GS upon 1 plus minus GS HS. Use positive sign for negative feedback and negative sign for positive feedback. Negative feedback means what? When output is less than input, that is known as negative feedback. When output is greater than input, then it is known as positive feedback. negative feedback. When output is less than input, it is known as positive feedback, and when output is more than input, then it is known as negative feedback. Therefore, the above transfer function can be represented as Rs into this block Gs divided by 1 plus minus GHHS is equal to Cs. Therefore, this is known as closed loop transfer function of the system. Now we will stop here, and in next lecture we will see rules of block diagram reduction.